everyone, I'm Yip-Si Tong. Here I'm going to talk about the beginning of the universe based on the Big Bang theory. The general process of Big Bang is not difficult to understand, but in this video I'm not going to just talk about the process. I'm going to have a deeper discussion about how does the matter create from nothing, from a singularity explosion to become gradually create the whole universe. So first, how does matter comes out of nothing? Let's have a look at an interesting phenomenon. We call it Schrödinger effect. In a vacuum, totally empty, but there is an electric field. As long as the electric field intensity exceeds 10 to the power of 18 volt per meter, positrons and negative electrons can be excited in the vacuum. They just appear out of nothing. So this phenomenon tells us energy plus vacuum can produce particles. Although matter cannot be exist in the vacuum, but there are various fields, electron fields, quarks fields, Higgs fields. As long as the field energy is given, particles can be excited. For example, if we give energy to the electron field, the electron can be excited. If we give energy to the quark field, quark can be excited. Therefore, actually all the elementary particles in the Standard Model can be created in this way. The second part, the process of Big Bang. Within this time, all the physics laws we know are invalid, because the four fundamental forces may be unified at this time. And first, gravity separates out, and then strong interaction separates out. At the temperature of the 10 to the power of 15 K, electromagnetism and weak interaction separate out. So why are the four fundamental forces separate? That's because the temperature change of the universe caused the phase transition. As the temperature of the universe decreasing, there are three phase transition, finally cause the four fundamental forces to separate. The essence of phase transition is symmetry breaking. The universe was originally highly symmetrical, and then there are three symmetrical breaking. Every breaking causes one force to separate. Currently, humans can verify the last symmetry breaking of the electromagnetism and weak interaction by using the particle collider. If the temperature exceeds 10 to the power of 15 K, these two forces will completely unified. Let's think about another question. What would a completely symmetrical universe look like? As we know, when the particle excitation happened in the vacuum, the positive and negative electron must come out at the same time. If the positive and negative electron meet each other, they will annihilate it into photons. If the universe were completely symmetrical, everything will turn into photons. But there is something happened. We call it CP violation. It's kind of symmetry breaking. The symmetry breaking causes the positive matter is much more than the antimatter. That's how we have the current positive matter universe. Actually, there are several symmetry breaking occurred after the Big Bang. Our universe was highly symmetrical at the beginning, and then, as the symmetry was breaking again and again, the symmetry of the universe continues to decrease, eventually form our current universe. The last part, the birth of particles. As we know, the higher the energy, the shorter the wavelength of light emitted by an object, and the greater energy of a single photon. When the energy of photon is large enough, particles can be excited from the vacuum. Specifically, we can calculate the critical temperature of all particles. At the temperature of 10 to the power of 15 K, all the elementary particles in the Standard Model are excited, which means at this time, the whole universe is a bunch of particles. When the temperature of the universe is 10 to the power of 10 K, three quarks began to combine to form photons and neutrons. At the time of 3 to 20 minutes, the temperature and pressure of the universe are similar to the Sun. Nuclear fusion occurs at this time, but the atomic nucleus cannot capture the electrons because the temperature is too high. Even if it catches it, it will be dismantled by the extremely high photons. The universe continues to cool. When the temperature of the universe is 3000 K, nucleus can grab electrons to form atoms. Atoms evolve over hundreds of millions of years under the effects of various forces, eventually forming the stars and galaxies. This is how the current universe was formed. Lastly, let's have a conclusion into three aspects. The transformation. The universe was highly symmetrical, and then there are at least 7 times of symmetry breaking. The energy, the temperature decrease lead to the separation of 4 forces. The matter, the particle are excited from the vacuum. This is the end of the whole video. Thank you.